A drought is a period of below-average precipitation in a given region, resulting in prolonged shortages in its water supply, whether atmospheric, surface or groundwater. A drought can last for months or years, or may be declared after as few as 15 days. It can have a substantial impact on the ecosystem and agriculture of the affected region. Although droughts can persist for several years, even a short, intense drought can cause significant damage and harm to the local economy. Annual dry seasons in the tropics significantly increase the chances of a drought developing and subsequent bushfires. Periods of heat can significantly worsen drought conditions by hastening evaporation of water vapor. Many plant species, such as those in the family Cactaceae, have adaptations like reduced leaf area and waxy cuticles to enhance their ability to tolerate drought. Some others survive dry periods as buried seeds. Semi-permanent drought produces arid biomes such as deserts and grasslands. Prolonged droughts have caused mass migrations and humanitarian crises. Most arid ecosystems have inherently low productivity. The most prolonged drought ever in the world in recorded history occurred in the Atacama Desert in Chile. Causes: precipitation deficiency. Mechanisms of producing precipitation include convective, stratiform, and orographic rainfall. Convective processes involve strong vertical motions that can cause the overturning of the atmosphere in that location within an hour and cause heavy precipitation, while stratiform processes involve weaker upward motions and less intense precipitation over a longer duration. Precipitation can be divided into three categories, based on whether it falls as liquid water that freezes on contact with the surface, or ice. If these factors do not support precipitation volumes sufficient to reach the surface over a sufficient time, the result is a drought. Drought can be triggered by a high level of reflected sunlight and above-average prevalence of high-pressure systems, winds carrying continental, rather than oceanic air masses, and ridges of high-pressure areas aloft can prevent or restrict the developing of thunderstorm activity or rainfall over one certain region. Once a region is within drought, feedback mechanisms such as local arid air, hot conditions which can promote warm core ridging, and minimal evapotranspiration can worsen drought conditions. Dry season within the tropics. Distinct, wet and dry seasons emerge due to the movement of the intertropical convergence zone or monsoon trough. The dry season greatly increases drought occurrence, and is characterized by its low humidity, with watering holes and rivers drying up. Because of the lack of these watering holes, many grazing animals are forced to migrate due to the lack of water and feed to more fertile spots. Examples of such animals are zebras, elephants, and wildebeest. Because of the lack of water in the plants, bushfires are common. Since water vapor becomes more energetic with increasing temperature, more water vapor is required to increase relative humidity values to 100% at higher temperatures. Periods of warmth quicken the pace of fruit and vegetable production, increase evaporation and evapotranspiration from plants, and worsen drought conditions. El Niño. Drier and hotter weather occurs in parts of the Amazon River Basin, Colombia, and Central America during El Niño events. Winters during the El Niño are warmer and drier than average conditions in the Northwest, Northern Midwest, and Northern Mideast United States, so those regions experience reduced snowfalls. Conditions are also drier than normal from December to February in South-Central Africa, mainly in Zambia, Zimbabwe, Mozambique, and Botswana. Direct effects of El Niño resulting in drier conditions occur in parts of Southeast Asia and Northern Australia, increasing bushfires, worsening haze, and decreasing air quality dramatically. Drier than normal conditions are also in general observed in Queensland, inland Victoria, inland New South Wales, and eastern Tasmania from June to August. As warm water spreads from the West Pacific and the Indian Ocean to the East Pacific, it causes extensive drought in the Western Pacific. Singapore experienced the driest February in 2014 since records began in 1869, with only 6.3 millimeters of rain falling in the month and temperatures hitting as high as 35 degrees Celsius on the 26th of February. The years 1968 and 2005 had the next driest Februaries, when 8.4 millimeters of rain fell. Erosion and human activities. Human activity can directly trigger exacerbating factors such as overfarming, excessive irrigation, deforestation, and erosion adversely impact the ability of the land to capture and hold water. In arid climates, the main source of erosion is wind. Erosion can be the result of material movement by the wind. The wind can cause small particles to be lifted and therefore moved to another region. Suspended particles within the wind may impact on solid objects, causing erosion by abrasion. Wind erosion generally occurs in areas with little or no vegetation, often in areas where there is insufficient rainfall to support vegetation. Loess is a homogeneous, typically non-stratified, porous, friable, slightly coherent, often calcareous, fine-grained, silty, pale yellow or buff, wind-blown sediment. It generally occurs as a widespread blanket deposit that covers areas of hundreds of square kilometers and tens of meters thick. Loess often stands in either steep or vertical faces. Loess tends to develop into highly rich soils. Under appropriate climatic conditions, areas with loess are among the most agriculturally productive in the world. Loess deposits are geologically unstable by nature, and will erode very readily. Therefore, windbreaks are often planted by farmers to reduce the wind erosion of loess. Wind erosion is much more severe in arid areas and during times of drought. For example, in the Great Plains, it is estimated that soil loss due to wind erosion can be as much as 6,100 times greater in drought years than in wet years. Climate change activities resulting in global climate change are expected to trigger droughts with a substantial impact on agriculture throughout the world, and especially in developing nations. Overall, global warming will result in increased world rainfall. Along with drought in some areas, flooding and erosion will increase in others. Paradoxically, some propose solutions to global warming that focus on more active techniques. Solar radiation management through the use of a space sunshade for one, may also carry with them increased chances of drought. Types. As a drought persists, the conditions surrounding it gradually worsen and its impact on the local population gradually increases. People tend to define droughts in three main ways. Meteorological drought is brought about when there is a prolonged time with less than average precipitation. Meteorological drought usually precedes the other kinds of drought. Agricultural droughts are droughts that affect crop production or the ecology of the range. This condition can also arise independently from any change in precipitation levels when soil conditions and erosion triggered by poorly planned agricultural endeavors cause a shortfall in water available to the crops. However, in a traditional drought, it is caused by an extended period of below-average precipitation. Hydrological drought is brought about when the water reserves available in sources such as aquifers, lakes and reservoirs fall below the statistical average. Hydrological drought tends to show up more slowly because it involves stored water that is used but not replenished. Like an agricultural drought, this can be triggered by more than just a loss of rainfall. For instance, Kazakhstan was recently awarded a large amount of money by the World Bank to restore water that had been diverted to other nations from the Aral Sea under Soviet rule. Similar circumstances also place their largest lake, Balkhash, at risk of completely drying out. Consequences. Time of droughts can have significant environmental, agricultural, health, economic and social consequences. The effect varies according to vulnerability. For example, subsistence farmers are more likely to migrate during drought because they do not have alternative food sources. Areas with populations that depend on water sources as a major food source are more vulnerable to famine. Common consequences of drought include diminished crop growth or yield productions and carrying capacity for livestock. Dust bowls, themselves a sign of erosion, which further erode the landscape. Dust storms, when drought hits an area suffering from desertification and erosion. Famine due to lack of water for irrigation. Habitat damage, affecting both terrestrial and aquatic wildlife. Hunger, drought provides too little water to support food crops. Malnutrition, dehydration and related diseases. Mass migration, resulting in internal displacement and international refugees. Reduced electricity production due to reduced water flow through hydroelectric dams. Shortages of water for industrial users. Snake migration, which results in snake bites. Social unrest. War over natural resources, including water and food. Wildfires, such as Australian bushfires, are more common during times of drought and even death of people. Exposure and oxidation of acid sulfate soils due to falling surface and groundwater levels. Globally, drought is a normal, recurring feature of the climate in most parts of the world. It is among the earliest documented climatic events present in the Epic of Gilgamesh and tied to the biblical story of Joseph's arrival in and the later exodus from ancient Egypt. Hunter-gatherer migrations in 9500 BC Chile have been linked to the phenomenon, as has the exodus of early humans out of Africa and into the rest of the world around 135,000 years ago. Examples well-known historical droughts include 1900 India killing between 250,000 to 3.25 million. 1921-22 Soviet Union, in which over 5 million perished from starvation due to drought. 1928-30 Northwest China, resulting in over 3 million deaths by famine. 1936 and 1941 Sichuan Province, China, resulting in 5 million and 2.5 million deaths respectively. The 1997-2009 Millennium Drought in Australia led to a water supply crisis across much of the country. As a result, many desalination plants were built for the first time. In 2006, Sichuan Province, China experienced its worst drought in modern times, with nearly 8 million people and over 7 million cattle facing water shortages. 12-year drought that was devastating Western Australia, South Australia, Victoria and northern Tasmania was very severe and without historical precedent. The Darfur conflict in Sudan, also affecting Chad, was fueled by decades of drought. Combination of drought, desertification and overpopulation are among the causes of the Darfur conflict, because the Arab Baggara nomads searching for water have to take their livestock further south to land mainly occupied by non-Arab farming people. Approximately 2.4 billion people live in the drainage basin of the Himalayan rivers. India, China, Pakistan, Bangladesh, Nepal and Myanmar could experience floods followed by droughts in coming decades. Drought in India affecting the Ganges is of particular concern, as it provides drinking water and agricultural irrigation for more than 500 million people. The west coast of North America, which gets much of its water from glaciers in mountain ranges such as the Rocky Mountains and Sierra Nevada, also would be affected. In 2005, parts of the Amazon basin experienced the worst drought in 100 years. The 23rd of July 2006 article reported Woods Hole Research Center results showing that the forest in its present form could survive only 3 years of drought. Scientists at the Brazilian National Institute of Amazonian Research argue in the article that this drought response, coupled with the effects of deforestation on regional climate, are pushing the rainforest towards a tipping point where it would irreversibly start to die. It concludes that the rainforest is on the brink of being turned into savanna or desert, with catastrophic consequences for the world's climate. According to the WWF, the combination of climate change and deforestation increases the drying effect of dead trees that fuels forest fires. By far the largest part of Australia is desert or semi-arid lands commonly known as the outback. A 2005 study by Australian and American researchers investigated the desertification of the interior, and suggested that one explanation was related to human settlers who arrived about 50,000 years ago. Regular burning by these settlers could have prevented monsoons from reaching interior Australia. In June 2008 it became known that an expert panel had warned of long-term, maybe irreversible, severe ecological damage for the whole Murray-Darling Basin if it did not receive sufficient water by October 2008. Australia could experience more severe droughts and they could become more frequent in the future, a government-commissioned report said on July 6, 2008. Australian environmentalist Tim Flannery predicted that unless it made drastic changes, Perth in Western Australia could become the world's first ghost metropolis, an abandoned city with no more water to sustain its population. The long Australian millennial drought broke in 2010. Recurring droughts leading to desertification in East Africa have created grave ecological catastrophes, prompting food shortages in 1984, 85, 2006 and 2011. During the 2011 drought, an estimated 50,000 to 150,000 people were reported to have died, though these figures and the extent of the crisis are disputed. In February 2012, the UN announced that the crisis was over due to a scaling up of relief efforts and a bumper harvest. Aid agencies subsequently shifted their emphasis to recovery efforts, including digging irrigation canals and distributing plant seeds. In 2012, a severe drought struck the Western Sahel. The Methodist Relief and Development Fund reported that more than 10 million people in the region were at risk of famine due to a month-long heat wave that was hovering over Niger, Mali, Mauritania and Burkina Faso. A fund of about £20,000 was distributed to the drought-hit countries. Protection, mitigation and relief. Agriculturally, people can effectively mitigate much of the impact of drought through irrigation and crop rotation. Failure to develop adequate drought mitigation strategies carries a grave human cost in the modern era, exacerbated by ever-increasing population densities. President Roosevelt on April 27, 1935, signed documents creating the Soil Conservation Service, now the Natural Resources Conservation Service. Models of the law were sent to each state where they were enacted. These were the first enduring practical programs to curtail future susceptibility to drought, creating agencies that first began to stress soil conservation measures to protect farmlands today. It was not until the 1950s that there was an importance placed on water conservation was put into the existing laws. Strategies for drought protection, mitigation or relief include dams. Many dams and their associated reservoirs supply additional water in times of drought. Cloud seeding, a form of intentional weather modification to induce rainfall. This remains a hotly debated topic, as the United States National Research Council released a report in 2004 stating that to date, there is still no convincing scientific proof of the efficacy of intentional weather modification. Desalination of seawater for irrigation or consumption. Drought monitoring, continuous observation of rainfall levels and comparisons with current usage levels can help prevent man-made drought. For instance, analysis of water usage in Yemen has revealed that their water table is put at grave risk by overuse to fertilize their cat crop. Careful monitoring of moisture levels can also help predict increased risk for wildfires. Using such metrics as the Keach-Biram Drought Index or Palmer Drought Index. Land use. Carefully planned crop rotation can help to minimize erosion and allow farmers to plant less water-dependent crops in drier years. Outdoor water use restriction, regulating the use of sprinklers, hoses or buckets on outdoor plants, filling pools, and other water-intensive home maintenance tasks. Zero-escaping yards can significantly reduce unnecessary water use by residents of towns and cities. Rainwater harvesting, collection and storage of rainwater from roofs or other suitable catchments. Recycled water, former wastewater that has been treated and purified for reuse. Transvasement, building canals or redirecting rivers as massive attempts at irrigation in drought-prone areas.